Hello everyone, welcome back to the session on Boolean Algebra. We were actually discussing the postulates of Boolean Algebra. So let me finish that in this class. So in the last class we have covered some postulates up to law of associative. Now we will see what is the law of distributive, which is the next uh, postulate. So let me write it. It is the law of distributive. Now, in this postulate, the first postulate sub law is A and B are C. A and B are C is same as A and B are A and C. And it can be proved by using the same technique which we have followed in our last class. So I am giving this as a task for you. You need to check you need to check the validity of this equation by considering three columns, one for A, another one for B, another one for C. Then you need to take OR operation between B and C and take the AND operation between these two. Later, in the next column, you can take A and B, and in the next column, you can take A and C, and then you can take OR operation. Okay. So if you go through the previous video, which I have covered, then you can clearly understand how to check the validity of this law. So from this law, I can say A and B plus C is same as A and B plus A and C. Next, second law of distribution is A plus B, which is you can also pronounce it as A or B and A or C. Okay. So before writing its value, let me first simplify it, then you can understand easily. So here I am not using truth table. Here I am not using truth table to get its answer or to check the validity of this. I am just applying the postulates which we have already studied in our previous videos. I am using them in order to find its value. Now, first I am doing AND operation with A for both these two variables A and C. So the first term which you can obtain is A and A. Second term you can obtain is A and C. Later I am using this, which is B. Now, if you apply similar to this, okay, you can get it as B and A plus B and C. Now I got four terms basically. Now, from the previous postulates which we have studied, I can replace A and A with A. Next, I am writing A and C as it is. Next, from the law of commutative, I can write B and A as A and B. Okay, and it plus B and C. Now, what I am trying to do is I am taking A as common. If I take A as common, we know that A can be written as A and 1. Or if you have A and 1, you can replace that with A. So I am taking A as common, that's why I have A only now. Now, as I took A as common, in the second term, I will have C. And as I took A as common, in the third term, I will have B. Okay. And I am writing B and C as it is. Now it is equal to, now if you observe here, in all these three inputs, we are performing OR operation with all these three inputs. When you are performing logical OR operation, if any one of the input is high, automatically the output is high. So this entire value is 1. That's why I can write this as A and 1 plus B and C or BC. And it is equal to A and 1 is nothing but A plus BC. So this is the result for this equation. Okay, this is another law of distribution, right? Similarly, another law is, let me write another law, which is law of absorption. This law name is law of absorption. And under this, you have one law which is A and A or B is equal to A. Okay. So I can prove this without tabular column, or you can also do it. So if you apply A, means if you apply this law, which is law of distribution here, you will get first term as A and A plus second term as A and B. And then I can get here, in place of A and A, I can get A. And in place of A and B, I can get A and B as it is. Now by taking A as common, I can obtain 1 plus B inside the brackets. Now 1 plus B, it is OR operation. If any one of the input in OR operation is high, the output is high. In that case, you will have A into 1, which is equal to A. Okay. And you also have one more law under this. It is same as this one. I am writing this again. That's it. A plus AB can be simply written as A. Okay. Let me write the third law in law of absorption. Third law in law of absorption, which is A and A bar plus AB. You can use any variables, C, D, E, whatever may be the variables. I am just writing for your understanding. Now, applying the law of distribution here itself, I can get it as A and A bar as the first term, and as the second term, it has A and B, and it is equal to, what is A and A bar? It is 0. So 0 plus A and A is simply written as A, B. So its value is AB. This is third law of absorption. Let me write fourth law. For all these, you don't need a tabular column, because these means the proof for these postulates requires the requires the knowledge of basic postulates, which we have studied already. Now, next law is AB plus B bar is equal to. See, how can I write this AB plus B bar? See, you can apply the this technique, here, or else this one, right? So AB plus B bar. Now I can write this as B bar plus B into B bar plus A, right? B bar plus B into B bar plus A. How can I write it? Because see, I am writing this one, this one. I can write this as A plus A into A plus B, right? Similarly, this one. That's why I'm writing B plus B bar, A plus B bar here. Now, what is B plus B bar? It is 1. A plus B bar, I'm writing as it is. So, its value is A plus B bar. This is fourth law of absorption. Let me write fifth law, which is A plus A bar B. A plus A bar B. See, if you apply law of distribution for this, you will get the same thing. If you apply law of distribution for this, you will get the same thing. See here, it is A plus BC. A plus BC can also be written as A plus B. First, I am applying this B to A, then I will get A plus B. Then I am applying C to A, so that I will get A plus C. That's why here I wrote it as B bar plus B as the first term, then B bar plus A as the second term. Similar to this here. Okay. As I can write A plus BC as A plus B into A plus C. Here also I can write A plus A bar B as A plus A bar B into A plus B. Okay. So A plus A bar is 1. Hence you will get A plus B as your answer. Okay. This is called as law of absorption, which looks opposite to the law of distribution. Okay. Next, we'll see the last law, which is law of double complement. Law of double complement, or law of double negation. Law of double complement or law of double negation. Double complement or double negation. Okay. Now, It simply says a thing. When you are applying complement for a variable two times, you will get the same variable. That is the thing, which is very simple thing. For example, here I am considering variable a, and I am considering a complement, and I am considering a double complement. So first, if a is 0, a complement is 1. As I am applying the complement again, I will get 0 again. If a is 1, a complement is 0. As I am applying the complement again, I will get 1 as it is. Now, if you see these two columns, you will get the same entries, right? A complement means a double complement is same as a. It is called as law of double complement. These are the basic postulates or basic laws that you need to understand before minimizing a Boolean function. In the next class, we will see some theorems related to this Boolean algebra, and then we will go for minimization of switching functions. Thank you very much.